Okay, the timing has worked out really well on this phase 3 portion of the lab. And that is because the first two nuggets that I've done that have pieced this together really have focused on what I would call CCNA content, meaning the router configuration, getting routing set up, setting up dynamic NAT and NAT overload, where we have all of our addresses at the branch office now translating to a pool of addresses that access the internet. We set up static NAT going to the server. We tested everything. It's good. So now we're going to focus on getting the branch office connected to the corporate office. Now, I wasn't planning on doing it this way, but just based on the feedback that has come in from you guys throughout this series, everybody wanted to know how to set up VPN connection. I shouldn't say everybody, but just an overwhelming group of people said, I want to know how to set up a VPN connection. So what I said, well, let's do this then. Let's create a VPN through the internet to our corporate office in GNS3 and test it and make sure it works. Now, it should work. I haven't tested this using GNS3 before, but everything should line up. It should work, and this is going to be exactly how we do it. But before we dive right in, I have to lay some foundation. First off by saying this is not on the CCNA exam. Currently, the configuration of VPNs goes beyond the CCNA. It actually even goes beyond the CCNP, routing and switching. This is something that is pulled out of CCNP security, but it actually worked out quite well because I wrote something I'm going to give to you back when for creating site-to-site VPNs with pre-shared keys, just kind of a step-by-step guide that I wrote for one of my CCNP security courses. I'm going to add to this, which will help document and walk you through the thought process of what I'm about to do. So first thing is, this isn't on the CCNA exam, so don't panic when you get there. Second thing I wanted to bring up was one of the feedbacks that I got when I was looking the day after Christmas, if you can believe that. We're now 2 days after Christmas, but someone popped this over to me. He said, I surfed the web, I was checking out blogs and things like that, and he found a blog titled GNS3, My Technical Test for Employers, which I actually read it, and I thought, what a great idea. Someone hired this guy, whoever wrote this blog, to create a test that if somebody's surfing for employment, and they want to make sure they really know what they say they know. He said, I've created this test in GNS3, which any CCNP should be able to pass. And you can see that it's going down. It says, here's your topology right here. I'll blow that up a little bit. There's the topology, and then he includes the configuration files for GNS3. And then, did it again. And then here's the actual test where it says task 1, configure the 802.1q trunk, configure a static ether channel trunk, all this, and he goes down and down. And what was so encouraging to me, thank you, whoever sent this in, he said, at the very bottom of this, he said, most of this you've done a great job explaining thus far, which I'm receiving that as like, wow, that's really cool to see because this is a test for CCNPs. So a lot of what we've done in this is kind of prepared you. Now, again, this is what I would call a light CCNP exam because you don't want to slam a potential employee who maybe hasn't done some deep configuration in some time. But anyway, that was just really good feedback of just kind of the content that we've covered in this so far. But I also what I did is as soon as I saw that, I was like, man, I'm stealing that. I PDF'd that guy's website and created this, and I downloaded his config files. I'm going to include it with the series because I know how transient web links are to where, maybe in a couple months after I've released this series, people are going to go there and it's not going to be there. So I'm going to include this with the download pack for this series. Okay, so now what I want to get back to is our task at hand, configuring the VPN connection. And before I drag the lab right back over, I want to talk about why. What's the point? And I know you may have, when I was talking about the WAN links early on in this series, you might remember this, but why would this Nugget Labs organization choose a VPN connection to connect their sites rather than just buying a link between their offices? The big one, money. Really, it's going to be cost because internet connections are cheap, at least compared to dedicated private connections between the offices. And if you have a fast enough internet connection at each location, man, that can make a great site-to-site link through a VPN tunnel. The second reason I would say this is hugely advantageous is because when you configure a VPN, it automatically opens you to the world of remote access VPNs. To where now you've got the base configuration in place. You can have home workers, you can have teleworkers that are in hotels, all around the world that are able to connect into the office at any point in time through a secured VPN connection. Security-wise, it's solid. It's not something that you should fear because of the level of security that goes into it. Now, let me bring the lab back over, and I'm going to kind of talk through this as we do it. Let me just make sure we're at a good resolution there. Good. So we are down right here. It says, and let me squish over. Configure a VPN connection from or between the Nugget Lab branch office and corporate site using the following information. And I did put a little note, this is beyond the CCNA, FYI. And you will have to configure both the branch and the corporate router to do this. And then I kind of break down the requirements for the VPN. Now before we just start typing commands, I have to give you a brief overview. First off, let me work through these. I put interesting traffic. All subnets between both offices or at both offices should forward over the VPN connection. One of the first things that you need to configure when you set up the VPN is what traffic is interesting enough, or what I call worthy traffic. It's the traffic worthy to cross the VPN. We have to go into this router right here and say, okay, you know what? If somebody comes from, we'll just say 10.1. I'll just put 66.0/24, and they are accessing 10.1.32.0/24. That is worthy. I'm specifying that that's allowed to connect to the VPN. So whenever the router receives traffic for that, rather than just sending it off to the internet, it's going to say, oh, let's stop right there. Let's encrypt it. Here's your packet right there. Let's encrypt it, scramble it using all my methods, send it over here to this destination rather than just straight out to the internet in plain clear text, and let that guy decrypt it at the other end. I have to specify on the router, I have to go in there and say, router, these are the subnets that are allowed to cross the VPN. Now, in this case, the scenario was simple. All subnets at both offices should be able to cross the VPNs, but sometimes it's not that way. There's a lot of times you might say, well, maybe I'm in a multi-tenant building. I don't want that group to be able to get across my VPN, kind of creepy. Or maybe if they are allowed, they can only access these devices. You can get pretty restrictive with it. Second thing is I'm going to use a pre-shared key between sites, CBT nuggets -key, exclamation point, exclamation point, exclamation point. This is one way of authenticating the VPN, meaning that the other side is who they say they are. When these guys get ready to start up the VPN connection, he's going to come out and say, hey, I'm ready to start a tunnel with you. Now, from router 1's perspective, he's going to say, well, who's to say that I'm going to allow you? I should say corporate router 1. The corporate router 1's going to say, well, who are you and why should I allow you? And he goes, well, I'm the router that has the secret key, CBT nuggets key, and I'm coming from this expected IP address, the one that's configured on you to expect a VPN connection from. And corporate router goes, oh, yeah, that's right. I remember you. Yeah, come on in. You're now authenticated. Well, that works great in 2, 3, 4, 5, 6 different routers that are connected across the internet, but the longer that you use that pre-shared key, the more potential there is that somebody could compromise it. Somebody could figure it out and just take it over or whatever, connect to the VPN. Now, there's a lot of other layers that go in there. I'm not saying pre-shared key is by any means unsecure, but there is another way of doing this, and that is using a certificate server. And what that is you have a trusted server. Usually you manage it, although you can pay somebody else on the internet to manage it for you if you want to, but cheaper to manage your own. And what you do is you say, all my routers trust that server. That server is our central point of trust. That is considered the certificate authority. He is the authority over this. So anytime somebody comes in, he's going to say, hey, I'd like to establish a tunnel with you. And this guy says, well, how do I know that I can trust you? He goes, here is my certificate, which is signed by that certificate authority. And that signature cannot be forged. can get into that more in the CCNP security world, but it cannot be forged. And this guy goes, oh, okay, since you have this certificate with the stamp of approval on it from that guy, I automatically trust you. That's a lot more scalable because now I can go into this certificate authority. I can revoke certificates if maybe a site gets shut down or taken over by another company. I can issue new certificates, and it just makes it a lot easier than going into every site and typing in a pre-shared key and then having to change that pre-shared key at every site on whatever interval your company decides on. So that's the second thing, is we've got the interesting traffic. We're going to have to specify a pre-shared key. Then we get into phase 1 and phase 2 settings. Phase 1 is the foundation. You remember when I talked about VPNs a few nuggets back before we started this phase 3 lab? I was talking that VPNs go across the public network. And you can't just send an encryption key over the public network to the other side, because somebody in the middle is going to be able to get it and use it to compromise your VPN. So that's where we got into that public and private key set. You remember that, where each side has a public key that they can send to anybody out here, and then they have the private key that they keep private. It's the only way to decrypt this, and they encrypt this session. You remember all that? I don't want to rehash it all. It's a long discussion of how it's possible to do security. Well, that whole discussion is phase 1 and phase 2. When I'm saying phase 1 settings right here, the whole purpose of phase 1 is to create a secure foundation so that we can start and use our phase 2. Meaning, I have to start some kind of encrypted tunnel right here so I can send what's called the session key to the other side, and they can generate, it's actually generated, but they can exchange that session key between their two sides so that they can use that for all their communication. So really, the phase 1 tunnel, when you hear phase 1, or a more common way of saying it is ISAKMP, the ISAKMP tunnel, that's the negotiation protocol that sets up the phase 1. And again, I'm getting into a little depth, but I want you to know the point. The point is, phase 1, the whole goal is to set a secure, I'll just put security for phase 2. It's just allowing us to exchange our phase 2 keys, which we're going to use for all future communication. That's our AES 128. That's the session key, the one single key that is very efficient but not as secure as the asymmetric keys or the Diffie-Hellman. Again, I'm getting into that whole discussion. So phase 2, also known as the IPsec security tunnel, that's the actual VPN. So if somebody was talking about a VPN, they go, oh yeah, we're doing encryption on our VPN, chances are they're talking about phase 2. They're saying, okay, we're encrypting all our data using this key. But the only way they were able to exchange the AES 128 key for phase 2 is because they had a secure foundation in phase 1. Without that, they would send this key and somebody on the internet would compromise it. They would be able to see it. Does that make sense? So what we're going to do is we're going to go through and configure phase 1 and phase 2 together and walk through, and then I'll show you kind of the guide I created to help assist you, because there's a lot of pieces to it. So let's bring up our router. There it is. I've got I'm starting on the branch office router. Let's start there. So the first thing that we need to do is, well, I'm gonna go through the order. Let me just show you. This is the guide I created for the CCNP security track, which is creating a site-to-site VPN with pre-shared keys. I'm gonna work through this guide one by one, and then I'll walk through it. In this case, I was saying here's the phase 1, here's the phase 2, kind of similar to the lab that we are working on right now. First thing I'm gonna do is get into router 1. Go into global configuration mode and type in crypto ISAKMP enable. What that does is enable the negotiation protocol. Essentially, somebody created an automated protocol to help us set up the phase 1 and the phase 2 and to do a lot of the behind the scenes work that we would normally have to set manually, coming up with random numbers to generate secret keys and all that. You don't have to use ISAKMP, but boy, what a pain if you don't. It's one of those, everybody who knows what they're Well, I'll just say everybody uses ISACemp. It makes it so much easier. Otherwise, you're mailing floppy disks to each other, kind of with the keys and all that. You don't want to do that, right? So the first thing that we're going to then do is configure or create what's called our ISACemp policy. Now you remember I said phase 1 is also considered, or actually in our lab, I put over here, phase 1 is also considered the ISACemp phase, which is kind of just going to secure the foundation for phase 2. So we're going to create what's called an ISACemp policy. So I'm going to do crypto ISACemp, and the big one we're looking for is policy, and then you type in a number. It says, what is the priority? Now, again, consistently inconsistent with these numbers, Cisco has made the lower numbers the more preferred numbers for the ISACemp policy. Meaning, what I'm about to do is create a set of security. I'm going to say what encryption we're using, what kind of authentication we're using. We're going to get into what kind of Diffie-Hellman keys we're going to use. Remember that from our VPN security. I said, Diffie-Hellman was where you had that public and private key set, and on the low end is 768-bit encryption. Normal people use 1024-bit encryption. You can even go to 2048-bit encryption. What level are you going to use? What security keys are you going to use for phase 1? How are you going to authenticate all the other side? Put all of that into a big pot. I'll put, here's my encryption setting, my Diffie-Hellman settings, my authentication settings, my let's see, my hashing settings, to where we're putting a hash on the end of every single packet. Put that all into one pot, and you call that an ISACemp policy. Now, when these guys start communicating, they're going to need to find common ground to stand on. For instance, if this guy, let's say branch 1, router 1, the guy on the left, if his ISACemp policy number 10, remember you type in a priority right here, that's what we're about to type in, priority of protection suite. So I create policy number 10 that says, I want to use Diffie-Hellman, we'll say level 2, which is, I believe, 1024. I want to use SHA-1 as my hash. I want to use pre-shared keys to authenticate the other side. I want to, it's got all of these different things that make up my little chocolate chip cookie here, this policy. If that doesn't match exactly to the other side, like let's say the corporate router says, okay, I'm also using Diffie-Hellman level 2. Oh, I'm actually using MD5 as my hashing policy. Immediately it says, Here, let me grab red. Policy number 10, you're done. You can't use it. That policy doesn't work. So the next thing it's going to do is keep looking down in the list, saying, do I have a policy 11 or maybe 20 or 50 or something? It's going to keep sending policies until it can find something that the other side agrees on. Now, if the other side never agrees, what do you think happens? You don't have a VPN. It doesn't work. There's no fallback. So we're going to create our first one, and I'm going to name it policy 10. Number doesn't matter. The number does not have to match the other side at all. The reason I started from 10 is, what if I wanted to squeeze something in? Like, I'm like, oh, I want a more preferred policy. Maybe I'll make 9 or 8 or something. That way I have some room rather than just starting at number 1. So I'm going to go in. I'm now in ISACemp policy mode. Now what I'm going to do is start specifying all the things that I want to negotiate with the other side. Now, mind you, the other side has to have exactly the same policy. Doesn't have to have the same number, but it does have to have all of the same settings in a policy that they can agree upon. So, looking back at our lab, that's where it comes in. It says phase 1 settings should use the encryption AES 128. So it's as easy. I go, okay, well, encryption. Let me type that in. Encryption, question mark. Okay, I want AES, question mark, 128. Hit the question mark. Yep, that's it. That's all there is to it. Okay, so I've added that. That's now, I've made that little chocolate chip in my cookie right there. I've made this part of the policy. It's one piece has been added. So I look back at the lab. Let me bring that up. It says, okay, hashing should be SHA-1. So I look back and hit the question mark. I go, okay, right there. Hashing, which you remember tacks a little. Remember I said it's like a blender. You put all the packet stuff in a blender, hit puree. It spits out an answer or a number or a value that is put at the end of every single packet that's sent. So that way you're able to tell if something has changed. Well, this is the blender algorithm. I can either use MD5 or I can use SHA-1. A little history, both of them have been around for a long time. SHA-1 is the later and greater. Neither one of them have been broken. However, there is a big security buzz about MD5. Somebody said, in theory, there may be a way to break MD5 if you hit it with millions and billions of packets and all. Again, it's a theory that's never been proven, but it has riled enough of the security community that people are like, I don't trust MD5 as much as I used to. So you see everybody nowadays using SHA-1. So you type in SHA. Okay, done. I've added my next little cookie. Do you see what I'm doing here? I'm creating this policy number 10. Now let's go back to our lab, and it says, okay, the protection should be Diffie-Hellman level 2. Now, I don't have a protection. You can just see group it says set the Diffie-Hellman group. So I'll type in group, hit the question mark, and you have group 1, group 2, and group 5 that are supported on this router. Now it said use group 2. So I'll type that in and press the enter key. Now the context-sensitive help doesn't show you this, but if you're ever curious, you're going, well, what's group 2? You can just go to Google, type in Diffie-Hellman group 2, and right there you can see there's Diffie-Hellman group 1 is 768-bit, group 2 is 1024, group 5 is 1536-bit encryption. So the group number correlates directly to the strength of encryption. I believe it's group 7 is the 2048-bit. So again, you're choosing the strength of encryption that you want. Again, for those asymmetric keys, the public-private key set. Now, in this case, that is the only real stuff that it said was in the phase 1. But let's look back. And hit the question mark. It says, okay, we had authentication. Now I have right here, do you want to use RSA authentication, which that's the certificate based, or do you want to use pre-shared? Now I believe, don't quote me on this, but I believe pre-share, is it the default? Is there no default? I don't remember. But either way, it's a good idea to type it in. And how would you know that? Well, it says right above it, we're using a pre-shared key. The type of authentication is all negotiated in phase 1. What I usually do is just hit the question mark under this. There's not that many options. And I just go, okay, did I type authentication? Okay, did I type in an encryption? Did I type in a group number, a hash number? Lifetime, I usually use it at the default. But what you can do is type in lifetime, and I can say after 28,800 seconds, and I type that because I think that's the default. 28,800 divided by 60, so that's 480 minutes divided by 60 every 8 hours. So a lifetime of 28,800 seconds is going to be a lifetime of 8 hours. So every 8 hours, what's going to happen is the keys for phase 1 are going to be flushed, destroyed, and regenerated, so that the longer you use an encryption key, the more chance there is for compromise. So for me, I usually leave lifetime at the default, which I believe is 28,800 in the first place. If not, again, don't quote me on it. It's not too relevant right now, but that's one that I just let them figure out by themselves. So that's phase 1. Let me do a show run. Section crypto, and hit the put a do in there, and you can see right there's my policy, crypto ISACAMP policy number 10, encryption AES. You notice it dropped the 128. You start seeing this stuff all the time. It dropped 128 because you notice when I was hitting the question mark, I typed in encryption AES. If I would have just pressed enter there, the default encryption for AES is 128. So it would have just accepted that by default. So I see authentication pre-share. I see group 2, Diffie-Hellman group 2 is selected. But I also notice, you notice I typed in hash is SHA, but I don't see that reflected in my running config. Again, that is because hash SHA is the default. If I would have typed in hash, let me go back into hash MD5, and then done the same command, do show runs, show crypto. Now I see it in there because MD5 is not the default. So again, don't hear me say, oh yeah, you don't have to type that in. Never rely on the defaults. I never remember what the defaults are. I mean, even pre-share, you saw me. I'm like, I think I don't remember what the defaults are. I like typing them in. So you notice as soon as I typed in SHA again, it disappeared because that is the default. Just like you won't see no shutdown in a running config because that is the default. It is not shut down. So we've got phase 1 configured. Now we can configure phase 2. Actually, whoa, Jeremy, before we do that, let's go back to the guide. So we've got ISACamp enabled. We've got our policy created right there. Now we've got, it says configure the ISACamp identity. This is actually something that you normally don't have to do unless you're using host names, but you can go into global config mode and do crypto ISACamp identity. And I usually, well, the default is address, and that's what I typically leave it on. And that means the router will identify itself. Like branch router 1, when it contacts corporate router 1, will say, hi, corporate router 1, my name is, well, let me see. My name is 172.30.100.230, which is the public IP address that it's using to communicate. And so what the corporate router will do is say, okay, do I have any profiles, any pre-shared keys configured for that IP address? That's one of the first checks that it passes is, are you coming from the correct IP address? So the only other thing that you might want to use is the you can see, like, you could use the host name or a distinguished name. That's like where you can do the fully qualified domain name, like router1.cbtnuggets.com, that kind of thing. That's useful if your IP address changes all the time. Maybe you have a dynamic address assigned from something, or something that can't be relied on. But I would say 99% of the time, I always use the address. I can't think of a time where I've used the host name. So the last piece of phase 1, I jumped too early into phase 2, is we need to configure those pre-shared keys. We saw in our lab that the pre-shared key between the sites should be cbtnuggets key, but we never assigned that. So what I'm going to do is go into global config mode. Nope. There we go, global config mode, and do crypto ISACamp key. Hit the question mark. It says, okay, what key do you want? Is it going to be an encrypted key, or is it going to be an unencrypted key? Now, don't be deceived. Don't think, okay, well, if I type 6, it's more secured. No. That means if for instance, I did a show run, and maybe it was encrypted in the show run, and I just wanted to copy and paste that encrypted version of the key into the config, I could do that by typing in the number 6 right here. But I'm not going to do that. I'm going to type it in plain text, which means I'm going to type it. It's not going to be any kind of encrypted version of it. And the key is, I'm actually reaching over and copying it and pasting it here. There we go, cbtnuggets key. That's the key that we said it should be. Then it says the person that's associated with is, I don't know, that's going to be corporate router. So let's jump over there and do a show IP interface brief on the corporate router. It's this guy. 172.30.100.240. So what I'm saying is, this guy, when he comes to try and start the VPN tunnel with me, that's the other side of the connection, he better have this key. Otherwise, we won't work. Enter. So now, I'm done with phase 1. I've got all those pieces put into place. Now we can do phase 2, which the first piece of it is considered creating a transform set. And I know right about now, if this is your first time seeing a VPN, you're going, this is insane. Who does this kind of stuff? A lot of people. It's a common config. And once you're used to it, I know it sounds crazy for me to say this. Once you're used to it, you're going to go, oh, the VPNs are a piece of cake. But this is one thing you'll always say. There's just a lot of pieces to remember, which is why having a little guide like this is so handy, because it's so easy to forget, oh, yeah, I got to type in the key. Oh, yeah, I've got to type in. It's just something to guide you step by step. Also realize that I would say VPNs are probably one of the most wizardized configurations. Like, a lot of people just use the Cisco SDM, the graphic utility, because they just don't want to remember all these pieces. So they let the SDM do it. I don't like that. Not because I'm like, oh, you've got to be command line. It's just The SDM just adds a lot of junk to your config and names it with names that aren't really intuitive. So you'll go back into a show run and be like, "What on earth?" It's like SDM policy one. Da, 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 da. It's just, it's silly. So anyway, it's much better if you do it manually, in my opinion. But let's now configure phase 2. So I'm going to do crypto IPsec transform set. Now, what we're going to do here is create a transform set which specifies the settings, the encryption and the hashing for the tunnel. Now, previously for phase 1, we created a policy, an ISACENT policy, right? Well, for phase 2, they call it an IPsec transform set, just the name that they use for that. So I'll hit question mark. It says, well, what do you want to name this transform set? So this is, you just got to remember it is all. I don't, I'm kind of dumbfounded here. Let's just name it VPN. How's that? Let's do IPsec VPN. So that way it stands out to us. So that's the IPsec VPN settings. Hit the question mark and it says, okay, well, what things do you want to include in this transform set? And that's where I'll say, well, I want the encryption AES 128. So I'm looking here, right there, AES. Now you might say, well, what's all these ESPs? It's extra sensory perception. Actually, it's in the encapsulating security payload. When IPsec first came out, the only thing it supported was AH, which is authentication header. It didn't do encryption or anything like that. They later introduced the ability using ESP. It's just it's the engine of IPsec. If you remember when I was talking about VPNs, AH and IPsec are the only real two engines that you have. So I'm going to say, well, I want to use encryption, so I'm going to use the ESP engine, and I'm going to use AES encryption. So we'll paste that in there. It says, well, what kind? And I'll say, well, 128-bit. That's what it specifies. Then I hit the question mark again. You notice that the encryption options have now been removed. All the DES, triple DES, all of this stuff is missing. And now it's just saying, well, do you want to use one of these hashing methods? Which I go back to our lab. And I wanted to use SHA-1 hashing, so that's where I'll say, okay, SHA. And you might be thinking, well, where's SHA-1? Well, there is no SHA-1 in the output, but that's the only kind that this router supports. Excuse me. So we've got, I can add the authentication header or compression if I wanted to, but I'm not going to. I'm just hitting the enter key. So I now have the transform set that is created. It takes me into this little transform set mode where I can change the mode of the tunnel if I want to. I'm not going to get into that. I'm just exiting out. Transform set has now been created. So now you can see optionally, if I want to, I can set the lifetime of the tunnel. Again, the phase 2 tunnel, how often I tear that down. And I just want to show you that when you set this, I don't know why Adobe Reader. Adobe, fix your bug, because it does copy to the clipboard. So I'm going to go back to global config mode, paste it in lifetime. I can specify it in kilobytes or in seconds. So this is a pretty good alternative to where I can say, okay, after we've transmitted maybe, there's just a value I'm pulling out of the air, 20,000 kilobytes, which is about 20 megabytes of data, it will renegotiate the security keys. Not all of them, just the security keys for the phase 2 tunnels. So the shorter the lifetime you put on this, the more secure your tunnel is, because it's always changing keys. But the more overhead you're adding, because it's all constantly having to renegotiate keys, so you're going to end up having a slower connection by the time it's said and done if you change that too often. Again, I don't usually change the lifetimes unless I have a very specific reason to do so. That's why I put it in here as optional. Now notice I put can create the mirrored ACLs determining the traffic to be encrypted and the traffic expected to be received encrypted. This is what I was referring to in the lab as the interesting traffic. Now's a good time. I'm going to go in there and specify exactly what traffic is interesting or worthy to be encrypted over the VPN. And the way I do that is by using an access list. So I'm going to come over here to router 1, and I'm going to do a show IP route, because I don't remember what subnets were at the branch office. And right there. There it is. That's my static route. I've got 10.1.64.0 /21. That was essentially a list of all the subnets that existed here at the branch office. That was my summary route. Remember that? Got it from the spreadsheet. So I'm going to go into global config mode, and let's use a named access list. I'll do an access list extended. You want it to be extended, so I can be specific. Otherwise, it's going to encrypt everything. I'm going to say the extended access list. Let's see. The name of this will be interesting VPN. And I would normally choose a different name, but for now we'll just call it interesting VPN. Hit the enter key. I'm now in named access list config mode, so I need to tell the router what traffic is allowed or permitted to cross and be encrypted over the VPN. So I'm going to say permit IP, meaning every protocol. Remember, we type in what protocol we want. I'm going to say IP. From the source, and that's where I'm going to use that route I had up here, 10.1.64.0, but they don't let us type in the /21. We use the wildcard bit, so that was 0.0. Oh, what is it? Come back here. Let's do /21 is really 255.255.248.0 /21/20, that'd be 4 or 5. Yep, that's 248.0. So a wildcard mask would be 0.0. I'm just in my head subtracting that from all 255s, and that would be 7.255, right? Because that's the reverse, the opposite of that mask. So I'll go in there and say 0.0.7.255 is going to be again, this is from the branch office perspective. Remember, right now we're doing our sources. What sources are going to be encrypted? And now I really want to specify what destination. I don't want to say anywhere, because then it's going to try and encrypt everything and nothing will be able to reach the internet, because people can't surf the web using encryption that nobody else is configured to support. So I'm going to say, okay, this is going to be the subnets at the corporate office. So I'll bring my spreadsheet back into it here. And I've got the Nugget Labs corporate office is 10.1.0 through 63. So I even put the mask there for myself. That was nice and convenient for me. So we've got 10.1. Okay, so let's say 10.1.0.0, because we're going to put the first subnet right there, the 0. We don't put 63. That's the last subnet. So the first subnet, and then the wildcard mask is going to be, well, I can't do that off the top of my head right now. It'd be it's going to be, hang on, 0.0. And then what's 255 minus 192? 63. So 0.0.63.255. So this, I'm saying, permit or encrypt everything from the branch office over here to the corporate office. Those are all the subnets at the corporate office, and I can hit the enter key. Now notice when I looked at my step-by-step guide, it said create mirrored ACLs defining the traffic, meaning on the other side at the corporate office, I need to have exactly this source, the corporate, is going to be encrypted going to that destination, kind of mirrored and reversed ACL on the other side. We'll see that in a second. So I've got that piece now, and then finally it says set up the crypto map. Now let me just kind of bring it back here to the whiteboard. We've defined a lot of pieces, and if this is one of your first time seeing a VPN configuration, you're probably thinking, this is insane. I am never going to do this. This is whacked, because that's what I said when I first saw it. But again, the more you do it, and you'll do it a lot in the real world, a lot of people are setting up VPNs. The more you're like, okay, you might forget the pieces, but at least it'll make sense. So remember the three big things we've done. We configured the phase 1 policy. All right, the ISAKEMP policy, and we said, here's everything that goes in that chocolate chip cookie. We then, step 2, configured the phase 2 policy, which said what encryption method, what hashing method we're going to use for the IPsec tunnel. So now this step 3, and these are big steps. I know we did a lot of stuff in between, like configuring the pre-shared key and that kind of thing. But the third one is going to be to put it all together. And Cisco does that using a configuration called the crypto map. Horrible penmanship there, but that's it. It's the crypto, C-R-Y-P-T-O, crypto map. That takes all the different pieces that we have and puts them together into one place and then applies it to an interface, kind of like an access list. So here, check this out. I'm going to work through it piece by piece. Go to the router 1, and I'm going to exit out of the access list. So I'm going to do crypto map, and we'll name it. I'll just name it VPN map. Again, that we'll just need to remember that name when we apply it to the interface. And then it says, okay, what entry in this map do you want to make this? And I'll say, well, this will be entry 10. Again, we can put entries before it. We can put entries after it. Obviously, there's a lot of VPNs that can be configured in 65,000 entries. So I'm going to say VPN map 10, and I'm going to use IPsec ISAKMP to negotiate this tunnel. Enter. You don't want to do manual keying or anything like that. And it says, okay, hey, by the way, this is a new crypto map. It'll be disabled until you appear and a valid access list have been configured. Remember, this is the piece that puts it all together. So the first thing I'm going to do once I get under here, let me hit the question mark. You can see there's not too much in here. I'm going to say match address. It says, okay, what addresses do you want to encrypt? And it's going to ask for an access list number or name. So I'm going to scroll back up here and say, well, we created access list, interesting VPN, remember that right there, to define exactly what will be allowed to be encrypted. So I'm saying, okay, CryptoMap, this is your interesting traffic for the first site-to-site VPN. Enter. Then hit the question mark and let's say, okay, well, let's see the next piece. Okay, we've got some set values. So I'm going to say set the peer, this is the person that we're connecting to, and it says, well, what's the IP address? And that was router 1. He was at 172.30.100.240. So I'll paste him right in there. That's the peer. And if you might think right about now, you're going, where are you getting all this right now? Well, that's, again, using this little step-by-step guide I created. I've just got it over to the side on the side of the monitor, just using this as a guide to put me through this. And I will tell you, I've configured a lot of site-to-site VPNs, and it would still be a struggle for me without having some kind of reference, just because, again, at this point, you can see there's so many pieces to this. It would still be a struggle for me to do it without some kind of guide, to do it all from the top of my head. Now you can see I have set PFS, group 1, 2, and 5. Now in our lab, let me bring our lab up. One of the things that it said is on IKE phase 2, no PFS. What is PFS? PFS is perfect forward secrecy. It is, let's see if it shows it right here. No, it just says set PFS settings. It's perfect forward secrecy, which means normally what happens is anytime you get to a place where I'm ready to renegotiate the phase 2 keys, and I say, okay, I've reached 20 megabytes of data. Let's renegotiate our key, get rid of the old one, and do a new one. It only renegotiates the phase 2 keys and renegotiates those. Well, if I use PFS, what it's going to do is tear it all the way down to phase 1 and kind of redo the initial exchange of the public-private key and kind of start all over. It is more secure, but it's going to add latency anytime you renegotiate the tunnel. There's going to be kind of a pause. Again, depending on what kind of device you have, some of them have hardware to offload that process and whatnot. But if you're doing voice over IP over the VPN tunnel, sometimes you could cause a little gap in the conversation. Not always, but I'm just saying in this case, let me get back to it. It said no. Don't do it. So what I'm going to go into here in the tunnel, I'm going to, it says set PFS settings. I could type those in. Set PFS. And you can see I can set it, or I'm just going to leave it unconfigured. If you really are anal, you could do no PFS, well, no set PFS, and say let's yank that off. But you don't have to. That's the default. I'm just saying don't put that in there, because again, if it doesn't match, the tunnel won't form. The last piece. So we've got the address matched to the other side. We've got the peer set to the other side. We're not using PFS. So last piece is to tie in the transform set. That's the phase 2 encryption settings, which we defined up here. Remember, in ours it didn't look like that. It was, so I'll do set transform set, scroll back up, right there, where we created a crypto IPsec transform set, and we specified AES 128, SHA-1, and all that. So let's paste that in there. IPsec VPN, enter. That's now associated, and I've put all the pieces together. So let me just do a show run include crypto. Oh, not include section crypto. And you can see I've got my crypto map right there, VPN map 10, IPsec ISACamp. Set the peer, set the transform set, and then match the address. Now the last piece I need to, well, almost last piece, but what I'm going to do is go into, type the command, right? Brief, into fast Ethernet 0/1, which is my internet-facing interface. That's that guy right there. And I'm going to do crypto map, and then attach the crypto map to this interface, VPN map. Good. So now what I've done is, notice it's saying, okay, now I'm active, ISACamp is on, I'm ready to go. I've told it I'm ready to accept and initiate VPN connections with the other side. Now don't worry, I'm going to put all this into the answer key and kind of go through it again because we still have to configure corporate router 1, but thankfully that'll be a nice copy and paste deal. The last piece, and this is one of the most forgotten pieces, a lot of troubleshooting goes into this. Be sure to adjust NAT appropriately for the VPN connection. You remember in one of the previous nuggets, actually the last nugget I think, or the one before it, let me do section IP NAT. We set up NAT to say anytime somebody from this source address goes to the internet, essentially goes to this outside interface, I want to NAT them to this pool of public IP addresses that we created. Now that works great until a VPN connection comes along, because what will happen is NAT is processed first. It's going to hit this router, transform the people, and send them out to this public IP address, at which point the crypto map, the interesting traffic, no longer matches because we've NATed them to a public IP. They're no longer the interesting subnet because they've been transformed, they've been NATed, and it doesn't work. So what I have to do is, and this is why it's forgotten so often. Let me do a show run section. Let's do access list. I need to go into the NAT addresses, which is the addresses that are allowed or permitted to be NATed, and squeeze in an entry. So watch this. Let me exit out of interface config. I'll go into this access list. And you can see I've got my sequence numbers. Let me do a show access list. And you can see right now sequence 10 is set to permit, that subnet, which is permit them when they're accessing any destination. That's for our internet surfing address. So I'm going to squeeze in a 5. Let's just choose sequence number 5 in this access list. And I'm going to say deny this subnet if they are trying to access nope, actually it's right here. This destination. Now hang with me, think through this for a second. Let me go back into a show access list. What I've done now is I've squeezed in an entry that says, okay, this is the NAT addresses, right? And I've put those right here in my NAT command. I said I want to NAT from these addresses to these addresses and overload it. That's what we did in the previous nugget. But what I did was add an entry to it to say, whoa. But before I process that statement, before I process sequence number 10, I'm squeezing in number 5 here that says, if these branch office addresses are trying to access these addresses, which are the corporate, deny them. So the question then becomes, deny them from what? Deny them from being NATed. Not deny them from working. This isn't applied to an interface. This isn't an access group command, IP access group. I'm denying them from entering the NAT process right here because we can't NAT them. I want to send them normally non-NATed over to this. I'm going to let the VPN handle all of this transport. I just don't want NAT to get in the way. Does that make sense? That's intense. If you can get that in your head, that's an intense concept. But that's one of the quickest ways to have a non-working VPN is to forget to do that. Okay, good. That is configuring a VPN. And what I'm going to do now is take all that config that we just did, put it in the notepad file, and then adjust it to just paste it all into router 1, and I'll walk through that with you. Okay. I'm back. So here's what I've done. Let me wipe all of this off. I've gone in and created a log of what we did, and here's the branch office router 1, and we've got the crypto maps or the crypto ISAKMP settings. We've got the access list for the interesting VPN, the address NAT address modification to deny the addresses from being NATed. We went in and set up the crypto map and applied it to the interface. So what I just did is I did a copy and paste. I said, okay, well, here is the mirrored config for corporate router 1. Now, the beauty is it's very easy once you've got one side to do the other, because I just pasted exactly the same thing, but instead, for instance, where it said, okay, the pre-shared key is going to be 172, or sorry, CBT nuggets key for the address 172.30.100.240. From router 1's perspective, that's the other side. Again, let me just make sure everybody's oriented here. I'm on corporate router 1. Let me do a show IP interface brief. And corporate router 1, which is, I need to grab my pen again, which is right over here, is the .240. This side is the .230. Now, is that normal for the internet? No, of course. But you would just have different public IP addresses. So when I'm looking at my configuration, let me grab my, where are we? There we go. And I look at the mirror, I say, okay, well, when I'm connecting from branch 1, router 1 to .240, which is the other side, and for the peer, it's .240, well, when I flip and mirror the config, I say, okay, this is for .230, and the peer is for .230. And what I did was flip the interesting traffic. I said, okay, now we're coming from the source of 10.1 and going to the destination of 10.1.64. That's the branch office. Whereas before, you remember I was coming from the source of 10.164 and going to the destination of 10.10. That's the corporate office. So again, all I'm doing is just copy and paste, just kind of flip all the things over to the other side. The only other thing, and this almost caught me, is the corporate office has Fast Ethernet 0/0 as their public-facing interface. The branch office has Fast Ethernet 0/1, because obviously someone very inconsistent set up the the corporate side. Actually, I didn't even think. You know what's interesting is normally I personally always use the lower number as the outside interface, simply because I'm used to Cisco PICs and ASA firewalls, where Ethernet 0 is always the outside interface, and then the Ethernet 1 and beyond is the inside in DMZ and so on and so forth. So I usually always do it FA 0/0. I don't know why I did 1. But nonetheless, we have this. This is what we're working with. So now I'm going to go over to the notepad file for corporate router 1, and this is where it gets fun, hopefully, if it works. So I'm going to go here to corporate router 1, get into privilege mode, and just paste. Oh, went off the bottom of the screen there. There we go. Paste it in and applied. So at this point, well, let's see. I've got, let me do a show run section crypto. Got all the crypto map information in there. I want to make sure, I'm just going to, just for my own warm fuzzy feeling, I'm going to see if I can ping the other side, the .230. Okay, we're good. NAT is configured. It should be as easy as now pinging across the VPN. Well, let's actually bring the lab back up. Right there. So we've got, we're now in the testing. So at this point, we've got NAT configured. Be sure NAT is adjusted appropriately. So testing, it says Nugget Labs branch 1, switch 1 should be able to ping any of the VLAN interfaces on Corp switch 1, including, here's some sample one. Corp switch 1 should be able to ping any of the VLAN interfaces on branch switch 1. Good. That should, yeah, I'm just, my mind is, my mind's always trying to find problems. So I think that should work. We're on the corporate side, so let's just head over there first. So I'm on corporate switch 1. Well, I want to be on corporate switch 1, and I'm going to ping, it said to ping over to, from corp switch 1, I'm going to ping 10.1.64.1, which is the VLAN interface on branch switch 1. So here's our 64.1 that I'm going to ping. All right, so let's get our Terraterm secure CRT back up. So I've got corp switch 1. I'm going to ping to the internet, make sure that's working first. Okay, that's not a good start. Hang on, let's do a show IP interface brief here. Okay, so we've got the VLAN. Let's do a show IP route. Going 10.1.1.2. Make sure I can ping that. Okay, I'm getting there. And why are we not happy going to the internet? Let's check router 1. Hang on, actually, I don't know if I set up NAT on this guy. Let me do a show run, include NAT. I didn't. I should have somewhere. That wasn't part of the lab. That was. You want to watch me set up NAT? Here, if you don't want to see this, then you can fast forward. But what I'm going to do is let's do a show access list because I did create the NAT addresses. Okay, it looks like NAT addresses are just denying I don't have anything permitting. So let's fix this real quick. IP access list. And this, I won't put this in the documentation because this should have been one of the pre-configs. I assume the corporate router was configured where all our config is on the branch office router. So I'll do IP access list extended. NAT addresses. Paste that in. We'll do 10 permit, and I'll just paste this to any destination. Show access list. All right, we got the NAT addresses. That looks better now. So I'm essentially NATing anything from the corporate subnet to any destination, which is the internet, but denying them if they're trying to cross the VPN, meaning connecting to our branch office. So let's do a show IP interface brief. Have you gotten the idea I like this command yet? Let's go into interface FA00 IP NAT outside. Got a bunch of sub interfaces there, so let's do in. IP NAT in. I'm just tagging all those as inside interfaces for NAT. You can have more than one inside interface. So if I do a show run section interface, I'll be able to see all of I see my root interface, inside interface there, pretty much has nothing under it. And then underneath, I've got all of these. These are all tagging to different VLANs that are coming in. And I've got all of these flagged as IPNAT inside, IPNAT inside interfaces. Okay, so now, let's do a, well, I'm not even going to do a NAT pool on this side. Let me do, I'm just going to say let's do IP NAT inside source list. It was called NAT addresses. So I'm going to say the access list NAT addresses. And we're going to go just straight out to the interface. I'm going to do interface FA0/0 overload. That's another way of doing NAT. So I'll do a show IP, well, let's do show run include NAT. And I can see right here is I've got IPNAT inside source, so I'm going from these addresses, that's the inside of my corporate office, and I'm just sending them, and I'm going to use whatever IP address is on fast Ethernet 0/0, which is going to be the 172 address, this guy. Everybody's going to share that address, and we're going to overload it. So let's see if it works now. And it does. Good. So we now have internet access for our corporate office, which was a little bonus side of it. So let's now see if this guy can ping to 10.1.64.1, which should be the private interface. Again, private address. This should not, normally you cannot cross the internet with private addresses. So we're going to establish the VPN if our config works right, go through the internet tunnel, and be able to ping over here. Drum roll, please. Hey, look at that. My breath was held. Good. So we've got the first failure happened just because sometimes it's because of the ARP delay of the ARP process, but in this case it was probably because what am I trying to say? The VPN had to be set up. So let's we just pinged that guy. So let's go to the client data 66.1. So let's just do 66.1. Good. Okay, so we're crossing the VPN. And then it does mention some other things at the bottom. It says the branch office router should show the VPN status is active, and you can verify that by using these two. These are just two of many commands that you can use. These are two that I use all the time. I'm going to go back to the branch office router, branch 1. Let's do a show Crypto ISACAMP SA, which is the security association. This shows how many phase 1 associations have I established. And right here I can see right there is my phase 1. I want to see a state of idle, meaning the tunnel's established. I'm not negotiating anything. It's from I am the destination. This was the source. I see one underneath here that is a no state. That's probably idle timed out or something like that. These come and go. There we go. So this is the tunnel was active and it tore it down. That might have been a key renegotiation or something like that. So this tells me phase 1 is active on the tunnel. So let's do a show crypto IPsec. That's the phase 2 tunnel SA. And right there I can see, good, I can see this is a little more information. It says I've got the crypto map. It looks like it's working active. I've negotiated a security association from the local subnet right there to the remote subnet right here. And what I want to see is this. I want to see packets being encapsulating and de-encapsulating and all that. I don't want to see all of the, well, actually, I don't want to see these guys. I don't want to see a bunch of errors. And errors happen when something obviously is not working correctly. So again, just making sure, let's just do the ping repeat 100. Just get that ping going across there, and I should be able to come back here and just see those send and receive cranking up. Yeah, look at that. So we've got packets that are sending and receiving. The send errors are not incrementing, so that tells us that this is working correctly. So last test is going to be we did from corporate side, we did from router 1. It says the Nugget Labs branch 1 switch 1 should be able to ping any of the VLAN interfaces on corp switch 1, including these guys. So let's check it out. I'm going to go to switch 1, show IP interface brief. It's like my brain just types that without even thinking. So let that scroll down. So I'm going to be pinging to 10.1.2.1. Copy that to my clipboard. Let's do a ping and paste it in there. 10.1.2.1. That's not good. Let's try the other one, 10.1.3.1. It's also not good. Let me just make sure that those are indeed, let me scroll back up here, 10.1.2.1 and 3.1. Those are the IP addresses assigned there. Let's do a show IP route. Now wait a second. This doesn't make sense because I was able to ping the ones I was pinging from here when I was doing this is the branch switch one. So what's up with this? We've got a default. Oh, whoa, 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 whoa. There's the trouble. Okay. So here's what's going on. You see, we've got all these VLAN interfaces here on the switch. I mean, think of these. Hey, let me get some drawing room. Just clear all this off. Think of these as all back here. So I've got all the VLAN interfaces. VLAN, what were they? 64, 66, 68, and all the IP addresses associated. But right here, here's the issue that we're running into. This is a subnet 10.1.254.0/30. Remember we created this? This side, I think, well, let's just look. This side is, yep, .1. This side is .2. And I see the default route right here is pointing to .2. Well, here's the problem. This subnet doesn't exist. We didn't include 10.1.254 in our interesting traffic. Matter of fact, I don't even think that's included in our NAT addresses. Is it? Let me look. Show access list. Oh, okay, it is. It is. We've got 10.1.254.0 included. So when did I do that? Anyway, so that will allow this guy to ping the internet. Okay, good. So he's getting out. So let's just check our VPN map. So we've got, okay, interesting VPN. It is not included in the access list. So let's do this. I'm going to go into IP access list extended interesting VPN. Pop that in there. Permit IP. And I'll do 10.1.254.0.0003, right? That's a weird wildcard mask for the opposite of that. And that'll be anytime we negotiate this. So I'll Slap that in there like that, and let's go over to the corporate side. Matter of fact, hey, I should add that to my answer key while I'm right here. Copy. Bring that up. Interesting VPN. Paste. So I'm permitting that one to cross the VPN, and that, oh, man, wrong router. Shoot. That router. Paste. Okay, so we've got that side done. And then actually, I'll just do this while I'm here. Paste. Control X. Control V. Good, and just flip it around. So what I've done is I've gone to the corporate side and flipped it to say, okay, going back, then the corporate side should be able to access that subnet. So let me copy that to my clipboard. Let's go over to the corporate router and IP access list extended and interesting VPN paste. Good. All right, so let's do a show crypto ISACamp SA. Okay, it's still idle. What I'm going to do is I'm going to trash it. I'm going to do a clear crypto ISACamp SA. Oh, it's just enter. Yeah. And delete it because it needs to renegotiate the, there we go, it's deleting itself. It needs to renegotiate that tunnel because it's got new interesting traffic it needs to exchange with the other side. So let's do on this side clear crypto ISACamp. Trash the connection on that side. Show crypto ISACamp SA. Good, it's deleted. So now, let's give it a try. I'm going to ping, let's do ping 2.1 from switch 1. Are we getting somewhere? No. Matter of fact, it's not even showing up as trying to establish the VPN. Crypto SA. Let's try it again. Oh, wait a sec. Hey, look right here. Hey, look at the NAT addresses. We've got, these are being natted to the internet, but I never denied them from being natted. So hang on, we got to modify that too. Man, just stuff we're running into all on the fly. Access list, extended NAT addresses. Correct, that was the name of it. Yes. And I'm going to do, let's do a 6 deny IP 10.1.254.0.0.0.0.3 when they are accessing the corporate office, these guys. Good. So let's do a show access list now. There we go. Okay, so now, because, okay, what was happening is my switch was trying to ping out, NAT was kicking in and sending it out to the internet. So now I'm denying it from being natted, which happens first. So that should now I'm just got to add it to the answer key. So NAT addresses, add that deny statement in there. Good. So now let's give it a try. Come on. Throw me a bone here, people. All right, so let's do a show crypto ISACamp SA. Okay, that's good. So it's establishing. Oh, I didn't do the other side. Someone's yelling, wait, you forgot the other side. Show access list. Yeah, I never did the other side to you know what I mean. IP access list, extended, NAT addresses. Plug that in there. And let's do a, well, let's just get that whole line in there. Control A, change it to line 6 to 254.0.0.0.3. So now, because again, it probably was getting there, it's just the other side was not, when it was trying to reply back to those pings, NAT was kicking in. There we go. Okay. Wow. Did you follow that? I hope so. If not, good thing it's on tape, right? So again, the two things we ran into is this subnet was not being added to the interesting traffic to cross the VPN. So I added it to the interesting traffic on both sides. But then we had to go to the NAT process and deny this from being natted when it's accessing these IP addresses, because otherwise NAT kicks in and never allows it to cross the VPN. It just sends it off to the internet. Whew. So At this point, we have now seen the configuration of a site-to-site VPN. Do you see why they put it out of the scope of the CCNA material? There's just again, once you do it a few times, like you probably saw when I'm troubleshooting, I'm like, oh yeah, oh yeah, oh yeah. There's just so many pieces of it. You just have to get used to where to look. One more thing I want to show you before. Whoop, not my email. How about one more thing I want to show you right here before we go is the Show Crypto IPsec SA. Take a look. It'll show now two subnets negotiated. It's saying, hey, we've got the 10.1.64 accessing these guys. This many packets have been sent. But when I hit the space bar, it now has negotiated another subnet. It says, oh, this is now added as interesting traffic as well with this subnet mask. And they're now allowed to access that subnet. And you can see right here, 9 packets encapsulated, 5 de-encapsulated. Why the mismatch? Well, remember, the first time we pinged, I didn't have the other side configured to NAT back. So that's where it sent 5 packets that never got responded to because the other side didn't have its NAT configured. So, good. Configuration of a VPN in all its glory. I hope this has been informative for you, and I'd like to thank you for viewing.